All right, we are on section 5.3, page 4, our last page of the section. And we see here that we have a theorem that says side, 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 similar. So it's just like side, side, side in congruent triangles, that we just have to have the three sides, in this case, proportional. So that's why I'm not making the congruent signs. Okay? So they're in proportion. So basically, again, you can see that one triangle's just been stretched from the other. So if we have that the three sides are in proportion, then we know that the triangles are similar. So the next couple of examples, they're going to ask us to name the method that is used to show that the triangles are similar. So we're going to go ahead with this first one. What is it? AA, SSS similar, or SAS similar? Shows that these two triangles are similar. Well, we've got angle T congruent to angle W, and we have angle R congruent to angle U. So which case do we have? Well, we have two angles in each triangle, so that means we have AA. Second problem, we're doing exactly the same way. So they're telling us the sides are in proportion. TR is proportional to WU. TS is proportional to WV, so we better put 2 on that one. And then RS is proportional to UV. So this is saying all the sides are in proportion, so which one is this? It's side, 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 similar. Okay, finally our last problem for this section. We're told that we have the two triangles similar, ABC and DBE. Okay, so what you may want to do is just go ahead and draw the triangles. I think that makes it easier. So here's our big triangle, A, B, C, and then our smaller triangle. Okay, so D, B, E. There we have it. So we know that AC is 10, so let's mark that. We know that CB is 12, so that would be this side here is 12. And then we know that E is the midpoint. Okay, so E is the midpoint of BC, so it's easiest to look here to see that. Well, it certainly doesn't look like it's the midpoint based on this picture, but I'm sure this picture is used for more than one problem. But since it says it, it's true. So if it is the midpoint, we know that this piece right here is congruent to this piece here, or since the whole thing is 12, we know that this piece has to be 6, and this piece has to be 6. Okay, so the important thing is that we know that this piece, BE, on the small triangle is 6. Okay, let's see what they ask us for. They want to know what DE is. Okay, well, notice when we look at the triangles, we have the relationships. We know that the triangle is similar, the two triangles are similar, so the sides are in proportion. So all we have to do is set it up. Let's go ahead and set up the proportion as big triangle over little triangle. Okay, so what do we have? If we take the side of this one down here, let's say, AC, we can say that, let's go ahead and write the letters first. AC, what does that correspond to in the little triangle? DE. Okay, and then we also want to use this other one piece that we know. So in the big triangle, it's BC. What does that correspond to in the little triangle? BE. If you're not sure of these relationships, look at what they said here. AC, the first and the third, so that has to correspond with DE. Okay, the first and the third. BC, the last two, has to correspond with BE, the last two. Okay, so there we have it. So now we're going to plug in the numbers. AC is 10. What is DE? That's the one we don't know, so let's just go ahead and leave it as DE. And then on the other side, BC is 12 over BE is 6. All right, so when we go ahead and multiply, we're going to have 12 times DE. So we're cross multiplying here. Let's put that in. Okay, equals 10 times 6. All right, so what do we get there? We get 12 DE is equal to 60. We divide both sides by 12. And what do we get there? We get that DE is equal to 60 divided by 12, which is 5. And that answers our question. And it also completes our section 5.3, page 4.